Hey guys, welcome to another video. So today, another video in the 100 series, which is basically 100 integration questions in the Extension 2 syllabus, right? The 100 series, for those that know, covers questions from Coroneos's 100 and also the Next Education 100, right? Now, if you haven't gotten your hands on these, please email us at info@nexteducation.com.au and we can send you both sets of integrals. Also, if you're keen for past papers, past trial papers, we have trial papers as well on our website at nexteducation.com.au, or email us and we'll send them to you. Once you've done it, if you want the solutions, email us and we'll flick it right through. Guys, before I dive in to two questions from the next 100 in this video, as always, subscribe to the channel, please, if you haven't already done so. Tell your friends, and then once you watch this video, like the video at the end. Guys, let's dive right in now. First question in the 100, right? That I'm going to do today. Guys, I wouldn't say it's super common, and normally when they give it to you, they give you a bit of guidance. Sometimes they don't, right? Whenever you see a question, right, that basically has almost like a linear combination of cos and sine on the bottom with a different linear combination of cos and sine on the top, right? The trick, unless your teacher's really mean, right? Nearly all the time when I've seen this type of question, you can express the top as a combination of the function downstairs. So maybe what I'll do, I'll just circle the question and call that fx, right? You almost always express the top as a function, as an expression that is a combination of the function and its derivative. Because when you split it, if it's a function on the function, it's easy to integrate. And if it's a derivative on the function, we can use ln, right? So I guess what I'm trying to say is, guys, if that's the function, right, then the derivative of the function, now quickly differentiate that, that's minus 5 sine x plus 4 cos x, right? I'm going to, and maybe I'll get rid of this blue highlight, use pink. Right, I'm going to express or try to express this as a combination of A times fx plus B times f dash x. Yeah, because if I can do that, I'll split the fraction, because the first one's on fx. Once you do that, fx does cancel out and you get A. I can integrate constant. And if I get this on fx, then that would just be ln, right? So this is how I'm going to do it. I'm going to go let 22 cos x minus 7 sine x equals to A times the function itself downstairs plus B times the derivative, right? Yeah, because I'm trying to split the expression into two parts. Yeah, that work for this. Now, I'm going to compare coefficients, or I'm going to expand this. So if I expanded this, it'll be like 5A plus 4B times cos x plus 4A minus 5B times sine x. And if I compare coefficients, so 22 equals to that, negative 7 equals to that, right? So looks like simultaneous equations. So 5A plus 4B, so 22, 4A minus 5B, it's minus 7. Let me just quickly check that. Yeah, it looks right. Okay, now, without wasting time, guys, if you solve this simultaneously, right, you get, therefore, A equals to 2 and B equals to 3. Let me check that. 10 plus 12, yes. Let me check that. 8 minus 50, yes. Okay, so that's your A and B. So therefore, right, I now can split, so my integral, right, of 22, right, 22 cos x minus 7 sine x over 5 cos x plus 4 cos x can now be split, right, into a combination. So the first one is 2 multiplied by the function. Oops, I wrote cos twice. Should be sine. Then multiplied by the function over the function. Plus 3 times the derivative, which was minus 5 sine plus 4 cos over the function dx. And guys, just cleaning it up, that guy cancels out with this guy, right? So then I'm just integrating 2 there, which is really easy. 2x plus 3 times function derivative on function, so that's 3 ln of the function itself. Let's see. How's that? So, like I said, whenever you see a linear combination of cos and sine on the bottom, a different linear combination on the top, generally speaking, right, you can actually express it as a combination of a times function, b times derivative. Yeah? Hopefully that was okay. Guys, I've got one more question for you. The next one is one of my favorites, right? Sec cubed. Yeah? Now, people that, all my students know that one of my favorite integrals is sec x. This is like, sec x with like, the deluxe model of sec x, right? It's like the special release model of like, sec x, and I'll show you how to do this. So, because to start this is actually hard, right? So when it's sec cubed, now sec squared, I know the integral sec squared is 10, right? That's easy. Sec cubed is harder. To do this, we basically will need to split sec x into sec times sec squared. Yeah, now my students then will try to use identities, and then they'll find out that they sort of get into a circle. Actually, the step to do here is not to use identities, it's to use by parts. Now, with by parts, so we know the acronym of Lie8, right? Gives you the order of to choose a U substitution, but in this case, they're both trigs, right? They're both trig. So what do I do? Now, I always say this to my students, when Lie8 fails, come back to foundation. What does Lie8 try to do? Lie8 is an attempt to basically give you the U expression, the U function, to make the integration easier. So for example, they go, let U be logs first because it's really hard to integrate logs, right? Yeah. Let U be exponential last because it's really easy to integrate exponential. So I guess what I'm trying to say is when you define this, right? When you go let U equal to something and let dv equal to something else, if Lie8 fails, and they're both trig in this case, define dv first to be the function that you can integrate, right? And we know that we can integrate sec squared quite easily. Yes, we can integrate sec, but then that needs a hack, and it's been asked, let it be sec squared and let this be sec. Right? Now, if that's the case, then I know that du, derivative of sec is sec tan, and the integral of sec squared is tan. Yeah, so let's apply by parts. In fact, if you were smart about it, can you let the original be I? Because you'll see in a sec, excuse the pun, that you'll see a little bit of recurrence going on, right? Let's see, u times v, so that's sec tan minus integral of sec x, tan squared x dx, right? Now you use identities, guys, over here. Yep, we know that that equals to sec squared minus 1. Right, now it's going to feel a bit circular, but that's where the recurrence kicks in, right? In a good way. Minus, let's see, integral sec squared, or cubed rather, minus sec x dx. So that, if I expand it, is the same as I, right? So this guy here is I. And when I expand it all, it becomes like I equals to sec x tan x minus I plus sec x dx, which is good because I'm going to now combine these two over here. So 2 times I equals to sec x tan x plus, now, my favorite, right? Integral sec x, guys. For those that know to do it, the shortcut is to basically multiply top and bottom by sec x plus tan x, oops, plus tan x, right? Now, why do I do that? Because if you multiply by sec x plus tan x, the derivative of sec x is sec tan, that's on top, plus the derivative of tan x is sec squared, and that's on top as well. So it's lnable, right? That becomes ln sec x plus tan x, yeah, plus c, and then divide the two over, and you have your answer, right? Therefore, I equals 2. Now, how should I do this? So maybe I will do it as sec x tan x over 2 plus ln sec x plus tan x over 2 plus c. Guys, one of my favorites, but deluxe model, right? It's got the sec x in there, sec cubed, hard question. Hopefully that was okay. Look, 2 questions from 100. If you want more practice on those ones, feel free to email us and we'll send it through. Like the video, please, subscribe to the channel, tell your friends, and I'll see you at the next one. Thank you very much.